My name is Lara Uçan. In this presentation, I will be mainly talking about stars, and I will describe how a star is formed out of gas and dust, and then describe the different types of stars and their different life cycles, because every star has its own life cycle. Then I will explain what happens when different types of stars burn out. Then I will conclude by explaining how different elements are produced by stars and make it to Earth. Okay. My paper discusses the life cycles of stars and their role in the formation of elements. And it actually begins by highlighting Wordsworth's description of stars, because I wanted to emphasize the need to explore the stars' inner qualities beyond their external beauty. And then the paper directly delves into the different stages of a star's life. Birth of star. Stars are born from nebulae, cosmic dust, and gas clouds. And gravitational collapse, triggered by factors like cloud collisions or supernova shock waves, these things lead to the formation of protostar cores, and these cores consist mainly of hydrogen and small amount of helium. However, protostars are not considered real stars until they can initiate hydrogen fusion. The formation of an accretion disk supports the growing star, and this allows to increase its mass. As the protostar gains mass, its heat rises, and this leads to the emission of powerful radiation. And protostellar winds caused by the interaction of this radiation with its surrounding gas and dust, and this helps remove angular momentum and facilitate further mass accretion. The final stage is nuclear fusion ignition, where stars begin to shine, actually. And this process involves atoms fusing to form heavier elements and releasing energy in the form of heat and light. Fate of stars. The fate of stars depends on their mass, and stars with sufficient mass can continue fusion until producing iron, after which they undergo supernova and may form a neutron star or black hole. And smaller stars collapse when they run out of hydrogen in their core, becoming red giants. The outer layers of red giants are blown out, creating a planetary nebulae, while the remaining core becomes a white dwarf. And apart from those, red dwarfs is the smallest main second star and burn for an extended period. Stars' role in element formation. After the Big Bang, the universe primarily consisted of helium, hydrogen, and small amounts of lithium. And stellar nucleosynthesis, through fusion reactions, generates new elements in the core of stars. And hydrogen fusion produces helium, while helium fusion leads to the creation of elements as heavy as nickel. The fusion processes involve the fusion of lighter elements into heavier ones, and this contributes to the formation of various elements, including carbon, neon, oxygen, and silicon. Okay. In addition to the stellar nucleosynthesis, heavier elements are formed through processes like the R process and S process, which involve neutron and proton capture. Cosmic ray spallation, where cosmic rays interact with nuclei, contributes to the production of lithium, beryllium, and boron. And the most exciting topic for me, the death of stars and element dispersion. The death of stars plays a crucial role in dispersing elements in space. Neutron stars merge, explosion of massive stars, exploding white dwarfs, and dying low-mass stars contribute to the dispersion of elements. And these events spread elements through the universe, including the formation of new stars and planets. In conclusion, the life cycles of stars and their contribution to the formation of elements make them fascinating and an inspiring subject to work on. Stars, like all great things, eventually come to an end, but their impact on the universe is actually far-reaching and essential. Thank you for listening to me.